Hi, my name is Victoria, and I'm going to be teaching you about limits. Please bear with me, this pen is really weird. I have a hard time writing with it. Okay, so what are limits? The definition of a limit is it is a point or value that a sequence function or sum of series can be made to approach progressively until it is as close to the point of value as desired. Basically, a limit is a point on a graph that a function approaches without ever actually reaching it. If you're wondering what a limit looks like, it's basically just like a normal function. Whoa. But then somewhere in the function there is a break or a missing piece. Here's an example of what a limit function would look like. So limit as x approaches 3 of 5x squared minus 8x minus 13 all over x squared minus 5. So this is a pretty simple problem. All you really have to do is just plug in the 3 for every time you see x. So, oh my goodness. Limit, sorry, like I said, bear with me. Sorry, my pen's acting up. So, you plug in the 3 for every time you see x. And so, once you put that in your calculator, you should be getting 8/4, which is actually 2. So, the limit as x approaches 3 of this function equals 2. Very simple. Now, not all problems are going to be that easy. Sometimes you have to go the extra step to figure it out because the function might have it to where the bottom portion of the denominator equals 0, and you can't have that because that means the function will be undefined. So, for example, we have limit as x approaches 2 of 3x squared minus x minus 10 all over x squared minus 4. Clearly, if you plug in a 2 in the denominator, that's going to equal 0. We can't have that. Therefore, we have to factor the top and the bottom to get rid of the whole. So we have limit as x approaches 2. Always write that portion down because that's part of the solution. That's always part of the problem. So you always have to write down limit as x approaches a value. So we have 3x plus 5, and then that's going to be x minus 2. That's that. And then we have x minus 2 and x plus 2. So now we can see that we have an x minus 2 at the top and on the bottom, so they will cancel. And so x equals, that's x, I promise, x equals 2 is the whole. That's where the whole is, and that is the reason why we could not just plug it in from the top portion. So now that we got rid of the whole, we can proceed to solve the problem just like we did the previous one by plugging in 2 every time we see x. So we'll have 3 times 2 plus 5 on the top, and on the bottom we will have 2, maybe. Just doesn't like 2's. Well, let's just pretend that's a 2. 2 plus 2, clearly not 0, it's going to equal 4. So, once you solve that, the answer is 11/4. So, the limit of x as it approaches 2 is 11/4. Of course, there are many other lessons about limits. This is just the basics of it. There are also limits approaching from the left side and from the right side, but this is just the basic outlook on them. Limits are important later on down the road in calculus whenever you're learning derivatives and stuff like that. But yeah, that's pretty much it.